We shall now take a look at algorithm to check if an input year is a leap year or not. Contrary to the normal thinking that if a year is divisible by 4, that means if you take a year, divide it by 4, and if the remainder happens to be 0, then it's a leap year, is not correct. I'll tell you why. First, let's understand what is a leap year. Every year we have about 6 hours. It is a little less than 6 hours extra in each year. So at the end of 4 years, we add one extra day to treat the fourth year as a leap year. But then there's a small problem. It is not exactly equal to 6 hours every year. It is slightly less than 6 hours. Since it is slightly less than 6 hours, over a period of time, the leap year thought process or the leap year implementation goes wrong. So, what the mathematicians decided, or what the people who created this calendar decided, is every year which is divisible by 4 is going to be a leap year, except that one or two exceptions. If it is a century year, like for example 1600, 1700, 1800, it must also be divisible by 400. So century years like 1700 is not a leap year because although it is divisible by 4, it is not divisible by 400. This is a leap year because it is divisible by 400. This is a leap year because it's a non-century year. This is a non-century, non-leap year. So the logic is pretty simple. If it is a century year, it should be divisible by 400, then only it's a leap year. Else, if it is a century year and not divisible by 400, it is not a leap year. How do you find if a year is a century year or not? If you take the year and divide it by 100, if the remainder is 0, that means it's a century year. If you take a century year, divide it by 400, only if the remainder is 0, that means it's a leap year. Every other non-century year is quite easy. You need to check whether it's divisible by 4 or not. So let's try to take a look at this logic and see how it works. First, what I'm going to do is I'm going to ask the user enter a year. So I'm going to input year into a variable called as year. Year is going to be a memory location like this. Okay, this is year. User is going to enter some value into it. Once he or she enters a value, I am going to use the else statement to find if it is a century year or not. I should first always check for whether a year is perfectly divisible by 400. That means if a year on dividing by 400, if the remainder is 0, that means it's a year like 2000, 1600 and so on, and it's a leap year. So first condition what I do is if year mod 400 is equal to 0, example is 2000. 2000 divided by 400, the remainder is 0. So year 2000 is a leap year. Once I say it's a leap year, then I have to straight away come here to step 4 and end of the algorithm. But now let's try to take a few other cases. Now say instead of 2000, the year was 1700. 1700 divided by 400, the remainder is 100. So this condition is false. Now 1700 divided by 100, the remainder is 0 because 1700 divides by 100 perfectly. So this is an example of not a leap year, and I will command halt. Now let's take one more case. If the year is input is 2008, 2008 divided by 400, remainder is 8. So this is false. 2008 divided by 100, remainder is 8. Okay, this is also not, this also condition is false. 2008 divided by 4, the remainder is 0. So 2008 is also a leap year. Now let's take one example which is not a leap year. Let's say we run it like this: 2006. I input a year. Year happens to be 2006. 2006 divided by 400. What is the remainder? Remainder is 6. So 6 is equal to 0 is false. So this condition fails. 2006 divided by 100. Is the remainder equal to 0? It is false. Okay, 6 is not equal to 0. So this is again false. Then here I come. 2006 divided by 4, the remainder happens to be 2. 2 is again not equal to 0. So automatically I come to the else condition where I write not a leap year and then I alt. So let's try to understand this algorithm in a much more simple and easy way. So the way we do it is the order of checking first by 400, next by 100 and then by 4 is important. If you interchange the order of these steps, your logic is not going to be correct. You're going to show year 1700 as a leap year. For example, if I put the first statement as year mod 4 equal to 0, it will show 1700 as a leap year, whereas 1700 is not a leap year. When we're actually writing a program, we will just be doing it one line, and I'll explain you at that point how we can write this entire logic in one line using a C++ code. So let's take a few years and try to test it out. Okay, 22, okay, 2020. Let's take the year 1600 and let's take the year 1800. All right, so these are the years I am going to test out. Input a year is 2022. 2022. So if I have like this 100 and I try to divide 2022, this is 20 times. So the remainder is going to be 22. Is 22 equal to 0? No. 2022 divided by 400, the remainder is 22, which is not equal to 0. So I leave that. I come to the next line. 2022 divided by 100, is it equal to 0? No. Again, the first should have been 400. 400 into 5 should be 2000. The remainder would have still been 2022, but the quotient would have been 5. Next time I'm saying year mod 100, that means I'm doing it by 100. Okay, first time the correction, it should be by 400. It is 20. This is 2000. So this is 22. In both cases, the remainder is 22. 22 equal to 0 is absolutely false. So this condition also fails. Then I come here, 2022 divided by 4, the remainder happens to be 2. So again, this is condition is false and automatically it's going to print not a leap year. Now let's take one more and I leave these two for you to check. Okay, you should always start with 400, 100, 4 and then automatically it's not a leap year. So this I have corrected. Accidentally I put 100. The first it should test is by 400. Let us take an input year. Input year is 2020. 2020 divided by 400, remainder is 20. So this condition is false. 20 is not equal to 0. 2020 divided by 100, remainder is 20. 20 is equal to 0 is again false. 2020 divided by 4, the remainder is 0. This condition is true. It's going to say 2020 is a leap year and then I'm going to alt. So please do check it with these particular numbers on your own, whether you are getting the flow. Just to repeat it, to understand or emphasize the importance, the order of these statements is very important. If you interchange any of these statements, you will definitely get the wrong result. Try doing it. You will increase your understanding much better.